All right, so let's take a look at our next example here. So it says, okay, so this is actually a proof. All right, so it says, write a proof for Theorem 1011 case 1, which states that the measure of an angle formed by two secants outside of the circle is half the distance. Okay, so again, here we have secants PS, right? PS and PT show this is true. So again, we're looking at angle P, arc ST, and arc QR. So notice they have this segment drawn here. This is very helpful because, again, it creates inscribed angles that we can use. It also creates a triangle. Okay, so we drew QT. That's the first step, right? But we're not going to write that down. So now let's use the triangle exterior angle theorem. So because we have QT there, angle SQT, this angle right here, is an exterior angle to this triangle PQT. All right, so we've created triangle PQT. So the measure of angle SQT is going to equal the sum of the two remote interior angles, which is angle P, the one we care about, and this angle here at T, QTP, or PTQ. So equals the measure of angle P, which is what we care about, plus the measure of angle, and they said QTR, right? They did not go all the way to P. QTR, sure. So again, this is the triangle exterior angle theorem. So again, we used this in the previous video too. So now, we want to leave this alone. So maybe we can substitute something for these two angles. Well, SQT is an inscribed angle. Its arc is ST. So this will be equal to 1/2 the measure of arc ST. So these are two equals, so we're going to plug this in for that, right? Okay. This guy right here, QTR, is also an inscribed angle. Its arc is QR. So this is also equal 1/2 the measure of arc QR. And again, that is because they are inscribed angles. That's the inscribed angle theorem. So through a substitution, we now get this equation, right? 1/2 the measure of arc ST equals the measure of angle P plus 1/2 the measure of arc QR. Now let's subtract the 1/2 of measure of arc QR to both sides. Sorry, the measure of arc QR. So again, in this step we did a substitution, right? Substitution. In this step we're doing the subtraction property. So I'm going to come over here if I can. So now we have 1/2 the measure of arc ST minus 1 minus, not equals, minus 1/2 the measure of arc QR, and that equals the measure of angle P. And now, so that's just subtraction. And now what we're going to do is we're going to do a distributive property. We're going to pull the 1/2 out in front. When you pull the 1/2 out in front, the measure of arc ST is here. The measure of arc QR is there. And that is what the measure of angle P equals to. And that is the distributive property. And again, this is what you want to prove. The measure of angle P is second, but again, it's the same thing as that. And there you go. And you're done. All right, so let's use these in problems now. Okay, so what is the measure of angle ABD? Right, so we want to find this angle right here. Let's call this angle X. So we're going to use the theorem that says that the angle ABD, is equal to 1/2 the difference of its two arcs. So actually, let's call this angle 1, like I think it was in the theorem. Let's call this angle 1. And let's call this arc X and this arc Y. So we're going to use the fact that the measure of angle 1 equals 1/2 X minus Y. Okay? So we know what X is. X is 151. We need to figure out what Y is. To do that, we have two of the three arcs. So we can take 139 and add that to 151. That is 190. And then if we subtract that from 360, we get 170. I'm sorry, 139 and 151 is 290. Sorry, that didn't make sense, right? And then if we subtract 290 from 360, that is 70. Oof, my fault. So that's 70 degrees. So then to find the measure of angle 1, we're going to take 1/2 of 151 minus 70. Use a calculator, whatever you want to do. That is 40.5 degrees. So the measure of angle ABD is 40.5 degrees. So again, that was the little helpful hint I told you guys, the fact that when you have a tangent and a secant, that the three arcs add up to 360. Okay, next we're going to find the measure of arc LM. So again, here's more of an algebraic question. We have angle 1 right there, call it angle J. This is x, this is y. Again, I should not use x, but I'm going to. So our equation, again, 2 secants, the measure of angle 1 equals half the difference between our two arcs, this x minus this y. So we know that this is 34 degrees, half of, now watch what I do here. Watch very carefully. This binomial I can put just as it's by itself, 6x plus 6. But then when I subtract this binomial, I got to put it in its own parentheses, 3 minus 5, because that minus sign needs to be distributed. So be very, very, very careful here. This has to be distributed. So we have 34 equals 1/2. So we have 6x plus 6 minus 3x plus 5. Combine your like terms inside the parentheses. So 34 equals 1/2. 6x minus 3x is 3x. 6 plus 5 is 11. Now, because these are odd numbers, I'm not going to distribute the 1/2. I'm going to actually multiply both sides by 2. What this is going to do, it just cancels the 1/2. This 2 does not go into the parenthesis. No, that is all one big term. This is all one term. So when you multiply by 2, it cancels with the 1/2. So if I come up here, 2 times 34 is 68. I was going to go into the 70s, but it's not big enough. No carrying the 1. So 68, and that equals 3x plus 11. And I'll subtract 11 on both sides. 59 equals 3x. Oh, I'm sorry, 57. 57. It looks like a 57. 68 minus 11 is 57 equals 3x. And then divide by 3. I like 57 better because that's a nice number. That's 19. So 19 is x. So they want the measure of arc LM. So that's going to be 6 times 19 plus 6. Use Desmos or a calculator, and that's going to be 120. So the measure of arc LM is 120 degrees. Fun-filled algebra for us all. All right, last but not least here. Oh, I'm sorry. So number 4 here, we're going to do this on the next video because this introduces us to our segments. So again, that was a shorter video. I apologize. The next video will include all of the segment problems.